Hello everyone. Alright, so this module we're going to be going over how to use different Python modules, packages, how to learn about those packages. That way you can start to see what options that they have to offer, the different classes, methods, and functions, because that's really what the package is all about, is reusing someone else's code to accomplish something that you would like to accomplish, and that's one of my favorite things about Python because there's a package out there for almost anything. So we're going to be looking at that, how to create our own modules, and then we're going to get into data manipulation, which is very important when it comes to software-defined networking because there's multiple forms in which you send and receive data when working with APIs. Our objectives for this module are going to be to use built-in help functions, learn about them, developing Python modules, importing modules, methods, and the different ways that we can import them using aliases, importing specific things from the module or package, where to go to learn about them, importing the modules from different packages. We're going to be covering and going a little in depth with the OS package. It's one of the ones I like to use a lot, but it's also very useful when it comes to automating your own system and working with your system through Python. And then finally, we're going to start to put together all this work that we've done with Python up to this point. And we're going to start working on some actual network automation using the Netmiko package. And so we'll be covering Netmiko network automation package basics. Overview. So what we're going to be covering in this lecture is going to be importing modules, the different ways that we can do it, and some of the different syntax. We're going to go over how to learn the module using things like the dir and built-in help functions. A couple useful modules that are listed in your book. They're just things that I have found very useful and that they seem to be coming up pretty common as I work more and more with Python. How to build our own custom modules, which we've already kind of touched base on a little bit when we did last modules, importing and exporting of the classes and methods and different functions from different Python modules. We're going to be looking at input and output, so that includes not only accepting user input using the input function, but Python's also very good at being able to read and work with different files and file types. So we'll look at how to open files, how to read them programmatically, and how to actually spit out the output in the different forms in which we can do that. And then we're going to go into parsing data, which is going to cover things like CSV, YAML, JSON, and XML. So those are some of the most common formattings that you're going to see when working with software-defined networks and just overall infrastructure automation. And then we'll be going into a demo, and finally our summary. Importing modules. So we accomplished that with the import statement, which we saw last week, and we would just do, import and then the name of the module, which imports the entire module. We can import functions, classes, and methods out of that module, whether it's custom built or it's a package that we installed via pip. We can also import just the functions, classes, and methods by using the from statement, because sometimes when you're working with a package or a module, you don't necessarily need everything in that module. Maybe you only need a specific method, class, or function. Import as, where we can assign an alias to it. As we saw last week, that sometimes the length or the name of the module can perhaps either get a little long or make our code more confusing, so we can assign an alias to that and then call it via the alias that we actually assigned. This is also where we import our packages. So how we did in, lab 3, I believe it was, where we were installing Python packages with pip. We are now going to actually learn how to work with those packages and learn more about them, because each one of them comes with their own pre-built modules, classes, and methods, depending on what it is that you're trying to do. And really, you should only import what you need, because that really, the whole point of programming in Python lately has been to make it very lightweight. So long gone are the days where we're writing code in one single block of code. We're breaking it up using objects. And this also goes to when you're importing modules or packages, functions, methods, whatever it is that you're importing. you could have a module that's quite big that covers a lot of different things, and perhaps you only need a specific portion of that. And that'll really come into play also when we start to learn about Netmiko and build out a Netmiko script. And then your import statement should be local only to the code that needs it. So as we're starting to learn that we can now break this up into multiple files, not every file needs to import all the modules, or not even your main code base needs to import any modules, methods, classes, packages, whatever. It doesn't need to import anything unless it's using it. So you only need to declare those imports in the actual file of the code that's going to be using that import. There are some built-in ways that we can learn the module. So we have the dir function, and that is very similar to the help option in Linux. What that shows you are the different classes, methods, and functions available for whatever it is that you pass into the dir function. So I like to kind of reference that to the help option because it doesn't give you a detailed view, but it does give you different options, which just based by the name of the option, you can then use the help function to view the more specific manual page on that particular function, see the different classes and methods that belong to it, as well as a description and examples of what it is that they do. A very easy one to kind of get started with is the date and time module. That comes natively with a Python 3 installation, so all you have to do is import it with the import date and time statement. And it can provide you things like your date, date time, time delta. Those are just some of the different options. So I use this one commonly, like when I'm doing network backups. I'll pull the date and then just pull the year, month, and date out of that date and then add it to the name of my backup. But there are more use cases for it, and I think this is a very good non-overwhelming way to get used to the dir function as well as the help, and then kind of get in there and see how the package operates and the different functions, methods, and classes that it has to offer. There is an Easter egg built into Python which provides the Zen of Python, so if you do just a simple import this, it will print the Zen of Python to the terminal. Some useful modules that are covered really in any programming are going to be your OS module, which allows Python to interact with your native computer, whatever it is that you're running, whether it be Linux, Windows. If you did go and grab yourself a copy of Automate the Boring Stuff in Python, there's an entire chapter dedicated to OS, which gets you in there. And like I said, one of the reasons I like No Starch Press is because they just kind of take a fun, short, sweet, and to the point approach to learning technology, as well as they kind of pull out some of the more common use cases that you would use it for. So we'll be looking at the OS module, how to create directories, move files around, things like that. You've got pprint, which stands for pretty print, and all that does is when you're returning a value from, let's say, an API call, and we'll be able to see an example of this when we start doing API calls. Sometimes those returns can get quite large and they'll fill up your terminal. So if you just use a standard print statement, it's just going to print the entire value out to the terminal with what's the word I'm looking for? With no regard to the person that is consuming it, because they're not assuming that a human is consuming it, they're assuming that it is a computer. So the pretty print function prints things to the screen in just a more organized fashion, which makes it more humanly readable. Date time, it pulls all that from the host, so we can grab date, time, we can pull the year, month, date from it, pretty much anything that you want to do regarding date and time, which is actually quite common, you can use using the date time module. JSON, which is used for working with JSON objects. The reason we keep bringing up JSON, the reason you're going to learn about it is because that's pretty much the main standard of sending and receiving data from a RESTful API server. And then you have Python requests. And Python request is used to interact with APIs. So it allows you to do API calls to the API server and just interact with it with different HTTP methods. And then you have Netmiko, which has come a long way in its most recent development. When I initially started with Python, we had what was called Paramiko, which was just basically a way to SSH into things. And what Netmiko did is it took Paramiko and then it added a lot of networking on top of it. So it's kind of like network focused SSH interaction with network devices. So it's pretty cool. I use it quite often. My biggest complaint is that when you get return values from Netmiko, you're getting them returned in the terminal format, which is meant for a human. So that's where things like XML, YAML, CSV come in handy, is because when you're working with information programmatically like that, it is actually a lot better when you're working with it programmatically to do something such as XML, where it gives you everything in a structured format. It just makes it easier to work with the data. Custom modules. You can create your own functions, classes, and methods, and then you can make your own module. If you remember from last week, when we initialized that Python interpreter, we are initializing an instance of Python right there so it can see everything in that directory or the directory below it. So you would just import, add the Python extension to the end of the file and import it by the file name, and then you could even import from that file different classes, methods, and functions. You'll notice last week that I named my file of classes models.py. I think that's a pretty standard way that most programmers do it. It's just like that models file kind of tells everybody, hey, this is where all my classes and functions are, but that really depends on the size of your program because it can scale pretty large sometimes. But it is good to keep them all in like a centralized place. You can also add a collection of functions and import those as a module. That way you're not declaring the function directly in your code. All your functions are declared in one place on one single file, and then you just import the functions as you need them into your specific program or code. All right, so here I am on the SDN VM, so I'm going to drop into a terminal real quick. Go ahead and make that a little bigger. Y'all can see. All right, let me do list. I'll make it just a tad bit bigger because I know the resolution can go down sometimes after I upload these videos. All right, I've already pulled down my repo for some of the examples that we're going to do. So I'm going to go ahead and go into the repo here, and I'll do a git status. I just deleted a couple of those off of there, so let me go ahead and just update that real quick. And that should be git add, boom, git status. All right, and git I forgot to. It's okay. I'll just leave those out of there because I'm not going to configure my entire Git and everything on this VM because I don't consistently work on here enough, basically. All right, so let me go into our module 4 folder. All right, cool. And now I'm going to go ahead and create a Python 3 virtual environment. Source my virtual environment, and I'll activate it. All right, sweet. Now I'm going to install at least the Netmiko package. Most everything else in here should be good for at least for this lab, except for Netmiko. That is the first package that we're going to be installing from pip or vip with pip. And what that package is, it's used for interacting with network devices via SSH. So I'll do a pip install Netmiko. All right, let me clear that. And now I'll do, I should have done this before, but because if I did a pip freeze before I did that install, nothing would have came up because it was a fresh Python environment. So if I do pip freeze now, you can see I've got quite a few different packages. All of these are required in order for Netmiko to work. So not only did I download Netmiko, but I downloaded everything else that would be required in order to actually use this package. And then I'm going to go ahead and, for good measure, because it's a good habit to get into, is create my requirements file. So I'll do pip freeze output to requirements.txt list and make sure my requirements file is good. All right, it is. Sweet. So let me go ahead and clear my screen. And now we will jump into our Python interpreter. Okay. So the first thing we're going to be looking at real quick is we already looked at importing modules. So we'll start with some pretty simple ones, and then we'll kind of work our way up to where we're working with Netmiko. Now we've got two different functions that are useful as far as helping us learn more about different modules or how to use the module. So the first one I'm going to do is date and time. So I'll do a dir, which is similar to the help function on the Linux machine. So if I were to enter in, the command, let's do list with the help option. You can see it kind of gave me just the quick little options right there. It is more abbreviated than, let's say, the man page for list, which is quite large because there's a lot of different options. So your help option, just gives you those quick little options and more of the common use cases scenario. So if I come back into our Python interpreter, actually let me go ahead and clear my screen. All right, and I do the dir function and I pass in, we'll start with date time. Now this is going to fail, and it's going to fail for a reason, because this is a built-in function. You'll notice I did not do pip install date time. It is not part of Netmiko. It is not included in my output of pip freeze. So I'll do a dir date time, and it says it's not defined. That is because I have not imported it yet. So I will do import date time, and now run that dir against date time. And there you can see it lists out all the different classes, methods, functions, and what all of my options are. And if I wanted to go even further, I could do date time dot, and then we'll notice you got these double underscores right here, which are usually used by the actual code or the package or program itself. That's usually kind of what that double underscore means. Really means that kind of you can leave it alone for the most part, or it's documentation even for this particular module. So down here is where we actually get into our different classes and functions that we wanted to do. So I could do date time, and then it gives me the output of date time and then the date time class and or method, whichever that is. We do not know yet, but it allowed me to go even further in there and gave me more of my options. So if we actually wanted to get the details on these, I would do a help date time, and this is very similar to entering man space a command in Linux. It gives you a nice little documentation page for that module, for that package, whatever it is that you're actually working with. So you can see it's giving me the reference, tells me what it does, a couple of different classes that are built into it. So we just looked at date time, and now we know that that second date time is a date time class. But we can also read on the different classes right here. So class date, and then what it accepts, year, month, and date, and then the different methods that it has. So I'm not going to go through everything, but it is important that you know where to go to for this documentation when you need to figure out if there's something that can be done with the package or how to accomplish something with the package. So I don't believe it's under this one right here. This is quite large, so if I wanted to get this down a little bit more, because that's a lot to go through, I can do a help, or I could just use the output of my dir. And it gives me, a couple of different options. And let's say I'm actually just trying to pull the date. I just want month, date, year. Well, I've got two options here, date and time, and then date, but just by the name alone, something tells me that that date is a little more what I'm looking for. If I did not know, that is where I would use the help date time. And then I could just, I just passed it, but the first one, there we go. And I could read up on this class date. And we got add equals to, represents, replace, C time, weekday, And then here it even says what the class methods are from ISO calendar. Today, that's kind of what I'm looking for right now. That's a really common use case because what I'm trying to do is get today's date pulled as a string without actually having to enter it. So it says current date or date time same as self dot underscore class from timestamp time dot time. And then it kind of gives a couple more methods and data descriptors right there. So I'll go ahead and exit out of that, and I'll do a help date time dot date, and then you can see it just spits out help on the class date in this module. So there it gives me again the class, replace, weekday, and then class methods defined here. And we're going to use that method today right now. So what I will do is, we've already imported date time, so let's go ahead and set, we'll do d for date is equal to date time dot date dot, and then the method was today. Let's see what we get back. All right, it didn't error out, so let's go ahead and print d, and there you can see it actually gave us the date. So we were able to pull the date and time and store it in this variable of d. And again, on that help on the date time, we could also do, let's see what happens if we do help date time dot date dot today. And then it just pulls out that method, but it's saying same as self underscore class from timestamp time dot time. Okay, well, let's go ahead and take a look at date and time again, and we'll look at date as well. And then it says year, month, and day. So each of those, as per the class, it created a date object of year, month, and day. So if I go back and I do d dot year, you can see it pulls just the year. D dot day, it pulls the day. D dot month, and it pulls the month. So now I could even set these to y equals d dot year, and month equals d dot month, and we already have d for the date, so we will do day equals d dot day, and print y, and there you can see it just printed the year, print m, and there's the month. All right, so that seems to be working pretty well. And that's just how we use our dir and help functions to learn more about built-in modules and or Python packages. We just have not got to Python packages yet. And if you'll remember up here, so I had to call datetime.date and then .today. So another way I could accomplish this is I could do from datetime import date. And then when I declare my I'll actually do this one as a full one, and we'll say it's we'll say today. Today equals date.today, print today. And there I didn't need to actually enter in datetime.date.today. I was able to make it a little more useful, and I only pulled what I needed because all I'm trying to do right now is get the date set as a variable, so I can have it as information that I can work with. And as you can see here, I used the class attributes of year, month, and day to even pull out the individual year, month, and day. All right, so we'll quit out of here real quick. I'll clear my screen. Let's go back into Python, and now what we're going to look at is the OS module. So if I do dir os, it's going to fail. So I will do import OS. Now this one's a little bit bigger than date and time. Actually, it's quite a bit bigger. What OS allows us to do is interact with our operating system using Python. So you could use this to automate file movements, making and removing directories, almost anything you can do via even a Linux command line you can do with Python. And you can do this across different platforms. So you could run, because Python can run on Windows, you could still run these exact same methods and use this package on a Windows machine, and it does not change. It still accomplishes the same thing. The only difference would be things like the directory structure is different on Windows than it is on Linux. But now that I've imported it, let's go ahead and actually start taking a look. So if I do dir os, you can see that's quite big. But if you were actually to read through some of these, so like for example, one of the first ones that's popping out is make mkdir, and just from my overall experience with Linux and yours as well, you can usually make out this stands for mate directory. But there's a lot of different options in here. So equally, the help is also as big, but it looks like it's a little bit more well documented than the date and time, but that's also because there's so much more going on, so it needs to be better documented so that we can work with it. But you can see it's pretty big. And this is one of the most common built-in Python packages that personally that I work with, because you're constantly, you're constantly, when you're coding, is having to manipulate files, folders. For instance, I just did a backup script where I backed up a bunch of network devices, and then it had to create a directory of the name of the network device, and then append the date and time to the name of the backup file. And that way we know when that backup was taken. I'm going to go ahead and quit just so that I can clear my screen real quick. Oops. So Python import OS. Now, first one I'm going to do is, I've already kind of gone through the dir output and pulled a few of the more common ones that you would be familiar with from, let's say, working with Linux. So I've pulled the get cdw. So if we do a dir on os.get cwd, I'm sorry, you can see there's not too much for us to get there now. All of it seems to be built-in stuff and required for the actual function to work. So I can just do help os.get current working directory. Returns a Unicode string representing the current working directory. Okay, so I'll quit real quick and do, let me clear my screen. We'll do a print working directory. All right, now I'll go to Python, import OS, and then I'll just do a D for directory equals os.get current working get cwd. If I print D, you can see it spit out the exact same path as the output of my print working directory. And you can just dir os, and so we've got make directory, and all these are in alphabetical order. So if we do get, where is it? There it is, get cwd. So that's where I would have got it, and then I went to use my help function to see what it's all about, what it does, and it does exactly what I thought, and that is gets the current working directory. So I'll quit, clear my screen, and then we'll do a Python again. Let's go ahead and list everything that we have here. So I've got venv as another directory, and you can see all of my files right here. So I'll do a Python and import OS again, and if from the output, you will also see we just saw the, there's also a list dir. So I will go ahead and do contents equals os.list dir. I'll print contents. And if you can see, it has now created a list of the contents of this working directory. So now I've got a list of all my files in that directory. Okay, and we'll do another one real quick. So just if I do a dir os list dir, you can see if there's any other options. There's not. And if I do help os.list dir, returns a list containing the names of files in the directory. Cool. And that's exactly what we got. All right, so we'll do one more. And actually I should have, so clear, and I'll do a list, and I'll do all, actually a list long. So we can see we only have one directory in here, and that is our virtual environment. The rest are files. So I'll go ahead and clear this, jump back into my interpreter. From the output of the dir os, I saw that there was a make directory. So what I will do now is os dot, and I'm not, so this is one isn't going to actually, so we'll do a help on it actually real quick. Make directory, and then you can say make directory, and it asks for the path, the mode, directory fd is none, help on built-in function, make directory in module POSIX, and it says create a directory. The drfd is not none. It should be a file descriptor open to a directory, and the path should be relative. Path will then be relative to the directory. Okay, so all that is a bunch of high-tech talk that's saying, you know, you can add in the path of where you want to make this directory, or by default it's going to use whatever it is, wherever it is that we are. So we'll do os mkdir, but because I'm making something, I can already tell you that I'm going to do Python directory. I have to pass in something for the name of the directory, but I don't need to output this to a variable because there's no output. It doesn't return anything. And now I can just do the, I'll do contents again. Actually, we can not store it as a variable as well, and so we'll just do contents.listdir, and let's see if it showed up. There it is, Python directory. So now if I quit, clear my screen, list, we can see we now have a new directory, the Python directory. We can do the list long, and we can even see it was still created by my user account and this user group, because I'm the one running the Python script. All right, input and output. So we've already worked with the input function where we are accepting input from the user. We've touched a little bit on get pass, which can be used to get that password from a user without actually showing the password being typed to the terminal. So it prevents you from shoulder surfers or screen crabs. But we've also got the open function, and the open function allows us to open different files and folders. Mainly text files, but you can open also things, you know, like CSVs, YAMLs, and XML files. So you just pretty much open the file, and then on the right here, you'll notice that we've got working with files with a little notation on what each syntax does. So R for read, W for write, because you need to open it in different modes. You got to remember, when you're opening these files, your files are stored on the hard drive. So when you open them with Python, you are then opening them to your memory, your random access memory, which is what Python is running on and your code is running on. It has to run in memory somewhere. So when you open it with a scripting language like Python, you are then opening that file in RAM with Python. So you have to tell Python which way, like how you plan to work with this file, or what it is that you want to do. So if you just wanted to read it, you could add just the R option. If you actually wanted to make changes for the file, you could use the W option. But you also have to remember to close your files, because if you do not close your files, most of the time it will not save, or you will have errors when you actually go to open up that file and retrieve the data that you put in there. You also have save options so that you can save the file, and then you have the with statement. So it would be like with open, and then you pass in the name of the file as well as the different operators over there on the right, which tell it how we're going to be working with the file. And you could also open these as and assign it an alias as well. I have in here text editor versus raw format. If you're looking at something in a text editor, you hit the enter key and you don't think anything of it. But when you're looking at it in raw format, it's actually going to add that /n in raw format, which stands for new line. So you've got to account for different characters that you enter, such as tabs, spaces, because although they may not be visible when you're looking at something in a text editor, they will still be visible by Python and that code. A few different documents in here. So if I do a list, you can see there's quite a bit in there. So because we're going to be going over YAML, JSON, CSV, and XML in a moment. But one thing I wanted to do is show you how we can use Python to actually open up different documents. So I will do a echo hello Python world, and I'll output that to a document, and we will call that text.txt. Okay, now if I enter into Python, what I can do is I can assign that to a variable and say f equals, and then I'm going to use the built-in open function, which if I do a help on open, you can see all my options up here. Help on built-in function, open in module, and it's basically just asking the file, and then it's got a default mode of R, but we'll go ahead and use the default for now. Not too much on it, but you can see that it gave a decent little output of the characters used for reading, writing, create a new file for writing, open for writing and append, binary, text mode, and I don't really use all these too much, but you can, and it is good to know that they're there. So I will do f equals open, and then I'll pass in that text.txt file, and we'll just leave it at that for now without specifying any argument, which we just saw in the documentation. It defaults to R for read. So that did not error out. So now if I do a print f, you can see it says text wrapper named text.txt, mode is read. So I basically have just opened this file as read only, and what this means is it's created an object for us. So it's created this text input output wrapper, the name of the file, what mode I have it opened in, and encoding is UTF. So there are some different read options, but I will cover those a little bit later, because that was what we'd have to do. I believe it's we'll do contents, and it's f dot, I'm going to say it's read lines. So now if I print contents, hello Python world, and then you can see right there that it added that that /n, which stands for new line. So there I was able to pull the contents of the file because I did a read line. So this is the first line, and then new line. So I believe if we do it, let's see what happens if we do a dir on open, because I don't know if it has that read lines in there, and it does not. Okay, I have to look up to see, because I know there's built-in options for that, so I'm gonna have to look up how we may have to use like help or something in order to find some of those built-in stuff, because I believe we can do I'll do just cont equals f dot read. If I print cont, does not print anything. Okay, and then you do need to close the file when you're done. And what that does is it closes it from memory. So when I open the file, I am opening it into memory. I'm pulling it from the disk where it's saved, and then I'm opening it to memory. Not too much of a problem when we're doing read-only like this, because we're not writing anything. So we haven't changed the file. All we did was open it, read it, so it's not too big of a problem, but we can still do f.close, and then that closed the file. So if I print f now, I still do have the object in there. Okay, that's fine. So I'm going to quit out of here, clear my screen, and then we will go back into Python. And then let's do an F for file again, and we will do open text.txt. And this time we will open it in write mode. So we're going to change that read default option to write. All right, and then I'm going to assign a variable to message. Actually, let's go ahead and read that real quick. So we'll do C for contents equals F dot read lines. Read lines F equals open text. Oh, it's because I opened it in write mode and not read mode, so we can't see it. But what we can do is I will create a message equals hello again Python world, and now we will do a f.write, and then we'll pass in the message, and there it says it wrote 24. I believe that's how many characters. We're still not in read mode, so what we will do is we will now close the file. We should save it, but because this is a text file, they're just really easy to work with. I'll quit, and then let's cat text.txt, and it says there, hello again, Python world. So it added the message that we put in there, but it also overrode it because we did the write option, not the append option. So if we go back in, I'll go ahead and clear my screen real quick. So right now, again, it says hello again, Python world. And you know what? I just don't like the fact that it's spitting all that out like that. So I'm going to do is I'm going to run the same thing again. So we'll do Python and file equals open text.txt. And we'll do write. And then I'll do message again. So I'm still not in append mode, but this time I'm going to do single quotes just to see if this works and we get it right. And that is, we'll change it back to just hello Python world. I'm going to add that new line character in there. And then we will do f.write message f.close, quit, clear my screen, and we'll cat. And there you can see now it added in that new line, which showed it as 1, and it didn't include it before my terminal. So just made it a little bit prettier, and that just goes to show you it did not add that /n as a character, it added the /n as new line. Now let's go back into Python, and let's open it in append mode. So we will do f equals open text.txt. We'll do this in append mode, and then new message equals isn't Python cool? And then I'll do f dot, I believe it should be right. I don't think it would need an append there, but let's see what happens. Okay, and so let's close the file. We'll quit out of here. You know what? I'm gonna, before I do that, because I know what's gonna happen if I do that, is let's open it again and let's change that message to, I'm gonna add single quotes, because if I use double, there's a good chance that it's gonna just add in the characters /n. All right, let's see if it takes it. This is the whole point of experimenting with the language. So now we'll do a f.write, new message, and then we'll close it again. We still had it open in pen mode, so let's see what that looks like. We'll do a cat. All right, cool. It took the new line character even with, isn't Python cool? Oh, it appended it twice because we opened it in append mode 2 times. So the second time it didn't, for our first one, it did not add that new line character because we left it out. And then I added it with the exact same message, but because I didn't have that new line character, it added it and appended it as just a single line. So still sort of accomplished what I wanted, but because I opened it in append mode and didn't add that new line, that's why it's all on one line. Again, this is why you come in and experiment with the language, because it's how you learn. All right, so we just did a text.txt, so we did write, read, and append mode. But what if the file doesn't exist? So what we can do here is we can do f equals open, and we'll say, we'll call this fscj.txt, and we'll open this in X, which as per the documentation should make the file even if it doesn't exist. So now I'll create a message, and that equals hello SDN networking world. I'll have my /n. And now we'll do a f.write to write it to the file. Takes exact. Oh, f.write message. And there it wrote it. So I'll do a file.close to close the file. Quit out of here. Let's list and see if we see that fscj.txt, and we do. So I'll do a cat fscj.txt and hello SDN networking world. So there we can use Python to also create files for us even if the file does not exist. And we can write to it. Okay, clear my screen. All right, parsing data. So there's a couple of different models or data models that we're going to be working with, or that are common when it comes to infrastructure automation. First one you may already be familiar with, which is CSV, otherwise known as comma separated values. The module to work with that within Python is called CSV, so you would just do an import CSV. And then the syntax for CSV is pretty simple. Each value is simply separated by a comma, and then each different object kind of has its own line in that it's on its own line in the file itself. And we'll be looking at some examples of that in a moment. Then you have JavaScript object notation, otherwise known as JSON. This one is quite popular. You may have heard it already being tossed around, and I think one of the biggest confusion points that I've noticed is some people, because it's got that JavaScript in there, believe that it is a programming language. It is not. It is just a way in which we format the data. The reason it's so popular is because most web applications are written in JavaScript. Therefore, we can make and interact with these web applications via their API, and it can return information in JSON format, which is extremely similar to Python dictionaries. They use the same curly brackets, they're key value pairs. Colon separates the key from the value. Quotations the same, the commas are the same. I think kind of the only difference is that the JSON object actually starts with the name, and then it starts the dictionary more as a list, but you'll notice that when we actually go to look at some of the examples. And then we have extensible markup language, otherwise known as XML. The module to work with this in Python is called XML to dict, so you would just do a import XML to dict, and that allows you to convert XML data into a Python dictionary. They use tags. That's what XML is really all about, is start and end tags. So if you've ever looked at, let's say for example, an HTML page. An HTML page uses these start and end tags as well, and it's actually the exact same format. Down there at example, I have a start and an end tag. So the start tag does not have that forward slash. The end tag does, and then we put our value in between those tags. So there you can see I've got an example value in between my two tags, and I've got a couple of examples that we're going to be taking a look at here. Biggest use case for those is going to be HTML. That's all pretty much written in XML, but it's not. It's HTML. It's just extremely similar. But also, this is how you communicate with network devices. So as we've been talking about software-defined networking and APIs, if I go back here, you can see JSON focuses on APIs, and I was talking a lot about web servers and the fact that web programs are written in JavaScript. Well, over here, if you have a controller, a software-defined networking controller, the human interacts with the controller via a web application. So there is a web GUI. You can click different menus, make changes, but your functionality is very limited to the graphical user interface when you're accessing it through a GUI. So when working with the JSON API or the RESTful API, the one that you interact with on the web server via HTTP, that uses this JSON formatting here. But if I wanted to interact with the network device directly via its API, and this is kind of a newer technology that's been coming out, I put that out because not your network devices in FSCJ's lab more than likely will not have this functionality on there, but this is a way for you to interact with the network device directly via a Python script and then get return values back in XML format, which gives you those tags, and that's a lot easier to work with than, let's say, Netmiko, where I log in, I run a command, and then it gives me the output in command line form, because then I've got to write a bunch of code in order to parse that data, clean it up, and I have no control over it. Using something like XML, where I've got start and end tags, I can convert it to a Python dictionary, and then I can work with it just like I would any other dictionary. Converting command line output to a usable Python format, such as a dictionary or list, is not the easiest task in the world, but it is great practice. YAML, which stands for YAML Ain't Markup Language. Some people believe it stands for yet another markup language. I don't know where that came from. I've actually had people put that out. Oh, YAML, it stands for yet another markup language. No, it stands for YAML Ain't Markup Language. The module for that is Python YAML. Python YAML is very easy to read. It's very easy to write. There's not a lot of syntax rules to it, but it is all about indentation. What is indented first? What's indented second? Biggest use cases for YAML is Ansible. All of your configuration files, your host variable files are all written in YAML. If you are working with Docker or Kubernetes, which is the new way in which we're building applications and deploying applications as containerized applications, they all use YAML files as well for their configuration, because Docker and Kubernetes is all a very automated process when it comes to actually deploying an application. You basically have a YAML file which serves as a recipe card, and I think that's a much better way to kind of think about YAML. It's very similar to recipes. That's why there's not a lot of syntax rules with it. It starts and ends with triple dashes or triple dots. You can put lists in there, and then some of the elements are key value pairs, lists, and then those dots, which are the start and stop of a YAML file. And again, down there it says their configuration files for automation. That's their biggest use case scenario and where you're most likely to run across the YAML files. So some of the different data formats that we're going to be working with in Python, we'll cover first CSV, then JSON, and we'll move into XML and then YAML. So I've got a few different example files in here, so I'll go ahead and open the example CSV just so you can see what it looks like. And to do that, I will open it with Nano. If you've never used a text editor in Linux, it is important that you know how to use a text editor in the command line. This is Ubuntu Desktop, so it offers us all these nice graphical applications that we can use, but if you're working on a server, the chances of those applications being there are very slim to none, and you probably won't have a graphical user interface. So in order to combat that, there are some of the built-in command line tools that we can use. The most user-friendly one is nano, so I will do a nano example.csv to open the file in a text editor. And here you can see we've got the file open, and all it is values separated by these commas. CSV is pretty simple in that form. Each value is separated by a comma, and then kind of each object has its own new line. And just a quick brief overview on nano. So here's all the commands at the bottom. So it's like Control O to write out, Control X to exit. So, and then you've got things like replace, copy, paste, things like that. So I will go ahead and do a Control X to get out of here. Now, once you get fluent with Nano, it is recommended to start learning Vim, which is a lot more complicated. It's pretty advanced, but Nano you are not guaranteed to actually find on a Linux server. Sometimes it's there, sometimes it's not. Vi is almost always guaranteed to be there. It comes standard package, or Vi or Vim. You can look up the history of that if you would like. But this is almost guaranteed to be here. So actually I'll do a Vim example.csv. All right, cool. So Vi example.csv. And now you can see I'm in the Vi text editor, which is just a little bit more complex. It's all built on commands that you need to know. So is navigation. So if I want to move around, I need to know how to navigate Vim with the different keys. And like I said, it's a little advanced, but it is worth learning because it's quite powerful actually once you start to get the hang of it and then become a little more fluent. But if you're just starting out with Linux, Nano will work just fine. So I'm going to do a Q quit. Open it in Nano. Now we can see it again. Then I'll go ahead and clear this. Jump into Python, and the module that we use to work with CSV data in Python is called CSV. So I'll do an import CSV, do a dir on CSV for good measure so we can see all of our options. And then I could also use the help function against CSV and read the manual page. So now let's go ahead and we'll do file equals open example.csv. We'll just go ahead and open it in read mode. And then we'll do file CSV equals csv.reader. And then we'll pass in the file that we just opened. All right, so let's see what happens when we print that. FCC. Oh. And then there you can see we have a CSV reader object. So we now have it opened to CSV. In the CSV file opened, and Python is picking up that it is a CSV file. So we could write to it. Let's see if I can pull it so we can see it. So I think I should be able to enter CSV. Let's see what happens. CSV reader object. Okay. And let's go ahead and CSV equals, turn it into a list, and then we named it, or we'll do C list equals list to turn it into a, convert the CSV to a list, which would all be available. Most of that information should be available in the, oh, so here we go. Dict reader, dict writer, error, quote all. I'm just going to go ahead and finish off this list one, and so we'll do CSV. Now let's print CList. And then we can see it created a list of all of my CSV objects. Let's see what happens if we do this dict CSV to CSV dot dict reader I'm a little unfamiliar with what it does, but hey, this is what I mean by you need to get in here, experiment with the language, and practice. And we will go ahead and do just the F file, which is how we originally opened it. So that variable still exists and still stays the same, but we're going to see what this dict reader does for us. Let's print dict CSV. See if it gives us an object. It does give us an object. Okay. Let's go ahead and CL equals, we'll do, see if we can do dict2, and then we'll go ahead and enter in dict CSV. Let's print CL. It's empty. That didn't work. I'm assuming that so if we do that dir against CSV again, I'm assuming then that means that this actually just takes a dictionary and converts it to CSV. But what we can do is we can always use that help function. I was just a little curious on it because I read it and I haven't used it yet. Dictionary dict reader, field names, rest keys, restful help on class dict reader, module CSV. Okay, I would definitely need to go and read up on that. See, help type self for accurate signatures. Okay, so it looks like it just takes your CSV information and or your dictionary and turns it into a CSV. At least that's what I'm picking up from it. Let's go ahead and quit out of here. Clear my screen. And now let's look at that JSON file. And if you'll remember, I have stressed that JSON is extremely similar to Python dictionaries, and that's because they are. So they start with start and end with these curly braces right here, and then the name of the JSON object. Here I did a bunch of restaurants, so my JSON object is named restaurants, which is the key. And then for the value, I've got a list of different restaurants. So I did McDonald's, food types burgers, type is fast food, Waffle House, which is breakfast and a diner, and Buffalo Wild Wings, it's chicken wings, and it's a sports bar. So this would be an example of a JSON object. So I'll go ahead and quit out of here. Python, and you probably already guessed, our module for working with JSON is JSON. So I can also do a dir on JSON, see what all my options are, and then also you can take a look at the help man page and read more on JSON. Looks like they even gave examples at the top, which is really awesome. I love it when they give examples. So we're going to do a file equals open, or f equals open example.json. And we'll just go ahead and do that in read mode. And I thought I'm looking for where's my JSON loads. All right, cool. Actually, I don't even think I need to do that one on this. I should be able to do f, let's see if this works. So we'll do fjson equals json.loads. Let's see if we can just pass in just the name of the file. All right, that didn't work. So we do have to pass in that f. So we'll do f.json equals json.loads. F, the JSON object must be string bytes. Ooh. It doesn't like that open file. Usually when I'm working with these, I'm actually, did I do loads? All right, let's try load. That worked. All right, cool. So if we type fjson class dictionary, so we should be able to do just print fjson. Cool. So you can see it converted our JSON object to a Python dictionary with a key of restaurants, and value is a list of different restaurants. So that's where I say it's very similar to work with. But if I tried to do a print f, you know, it's still saying, yes, this is just a text wrapper. I've got the file opened in read only, but it doesn't recognize that it's JSON or that it's a dictionary until we actually use that JSON load to load the file into its own variable that we called fJSON. And from here, it's the same thing as working with pretty much any Python dictionary. So I could even now do restaurants. I'll just do rest r equals, and then I did fJSON. Spelled restaurants wrong. I'm terrible with spelling, in case you haven't found. And so now I'm just assigning the value of this key, which is the JSON object, to the variable r, which should be all of my restaurants. So I should have a list of Python dictionaries after this. So I'll print r, and now I have a list of Python dictionaries. And if I even do a type r, it's going to let me know that it's a list. And I could work with this any way that I would any other list of Python dictionaries. The last two data types that we're going to be looking at are XML and YAML. I'm not going to get too much into the actual functions that you use in Python to interact with those two data types, mainly because I kind of feel we've beaten that up. It doesn't really change from data type to data type. You'll notice it's kind of the same process as importing the module. Those modules are listed in your DevNet Associate book in the chapter on Python modules to work with both YAML and XML. But what I will do, and I'll actually go ahead and open up Atom for this, is just go over okay, file, open folder, documents, SDN demo. And we'll go ahead and take a look at module 4, and I will open up the XML example. And let me double click that to save it open as a tab, and then I actually grabbed the output of a network device as well, so I'll show you that. And then we will open up the YAML file as an example, and then I grabbed one Ansible playbook that we'll take a look at. Alright, so XML, first thing is to define the version and the encoding. So here it's just saying encoding is UTF-8 and version of XML is XML1. And then after that, XML works on these start and end tags. So here I've got ships as my start tag, and then the end tag is all the way down here for ships. The end tag is annotated by this /. And then in ships, I've got four different ship objects that I've defined in here. So here's the first ship with its start and end tag, and you'll notice when I select it in Atom that it automatically selected my start and end tag for me. And then I've got the name tag, start and end, and then my value is in between. Same as in my ships, my value is still in between. I'm just doing it kind of in a nested format. So for my first ship, for name, it's USS Gettysburg. Type is it's a CG. Whole number is 64. Motto, deeds not words. And then I ended the tag. And I started a new tag. They do not need to be different because it will read each of these kind of as a list of ships. But I've got the start tag here. Name is USS Nimitz. Type CVN 68. Teamwork or tradition. And then third is USS Cole DDG 67. Gloria Mercies Virtuitus. And my last ship is USS Boxer, LHD-4, Honor, Courage, and Strength. If I wanted to add another one, since I've already saved this as example.xml, it's another great portion on code editors, is I'm just going to go ahead and do a start tag, like the first character, that first arrow, and then instead of typing everything out, I'm just going to hit tab right now. And you'll notice that it automatically created my start and my end tag, and I am already editing the name. So I will do ship, which is indicating that I want to create another ship. And then for the value, I'll select in between there, hit enter, come back up here, enter, and then I can just do the same thing. So name is actually what I want, so this one's good. And then I'll do tab, and we will do type, and then tab, whole, start, tab, motto. And I'm not actually going to go look up another ship right now, but you can see that now I would just enter in, USS Philippine Sea. They are a CG. What's their whole number? I think it's 68. I should know that. They used to be parked right next to me all the time. Motto, I don't know. So I'd have to actually go look that up. But you can see I'm just trying to show you how easy it is to actually create those start and end tags in a code editor, and one of the benefits and powers of the code editor. Now, XML is used for interacting with network devices' APIs directly. In a software-defined networking solution, we have the controller, which has a web server running on it, so we use JSON objects to interact with those APIs, and we will be seeing more of this when we start to work with it, now that we're starting to get into APIs and working with them. But this would be as if you were interacting with a RESTful API, which would be via HTTP, and you usually get your information back in this JSON format. If you skip the controller and go straight to the network device, you're more than likely going to get your output back as XML. And I do have a show IP interface brief output in XML form, so you already know what it looks like from the command line. And here's what it looks like returned from a network device in XML. So you can see up here, it even defines the XML version and the encoding scheme. And then it's just got some information on the fact that it's pulled from netconf, and that it's Cisco NXOS. And then the data, start tag, end tags all the way at the bottom. And here's the command, show IP interface brief, and it's letting me know it's read only. And as I go down, you can see each row basically shows me a different interface name, VLAN 1001. Here's the IP address of that VLAN. IP disabled is false. I'm not sure what that, it's probably the object OID on the device. We can see protocol is up, link state is up, and admin is up. So this interface is in a up and up state. And then we keep going down, and you can see we have more VLANs, more interfaces. And I just wanted to show you what the purpose of working with XML, because this was pulled directly from a device, Cisco Nexus Devices API. Now, YAML is used commonly in automation tools such as Docker, Ansible, and Kubernetes. And what YAML does, and the best way I'd like to describe it, is it's kind of like a recipe book or a menu. So here I've got restaurants, and I've got different objects named, or different key value pairs. Name McDonald's, type is fast food, and then I did just this little one for a menu and a list of items on the menu. I misspelled cheeseburger. Really bad misspelled cheeseburger. Cheeseburger, fries, Big Mac, and then I had Waffle House, diner, waffles, hash browns, eggs, Buffalo Wild Wings sports bar, menu, wings, burgers, and chicken. And the YAML file is started with these 3 dashes at the top, and it's indicated the complete end with the 3 dots on the bottom. There's not a lot of syntax rules to YAML. It is all about the spacing. So you can see that all of these are spaced almost exactly evenly, except when I started the list, these are indented a little bit more, because indentation is everything in YAML. So very easy to read, very easy to work with, but indentation is extremely strict, because that's how YAML differentiates between one object to the other, one key value pair to the other. An example of this would be an Ansible playbook. So here I've got an Ansible playbook. This is a real Ansible playbook. It doesn't have the end tags, but that's because this play is not done. It still has to pull data from the host files, and you would have to go learn a little bit more about Ansible before you start to get into that. But we can still see the 3 dashes at the top, and then this dash indicates the start of the play, which is the name, which is backup iOS, my host, which I have my lab environment put in there, my host, and we'll learn more about this actually when we do our lab on Ansible. Connection is going to be local, meaning I'm making an SSH connection from my control machine, which is this Ubuntu virtual machine, the SDN VM. And then I've got different tasks or different plays. So the first one, the name is backup iOS, and then I'm calling the module iOS config, and then that has different options. Backup, yes I do. What are my backup options? Well, I would like the file name to be called backup.config, and the path for the directory is going to be in the directory at the root, or exactly where we are, in a directory called backups. So there is my backups directory. And that's just an example of an Ansible playbook in YAML format. I believe the module for working with YAML is PyYAML, and I think XML it is just XML, but it could be XML to dict. I would have to look it up in the book just to actually confirm that though. But that is a YAML and XML file. And again, I'm going to kind of leave the coding off on this because the process is the same as it is with working with our JSON and CSV information. You still pretty much load it, open it, and then convert it to something that you can work with in Python, such as a dictionary or a list. All right, so the last thing we're going to do is build from scratch a quick little Netmiko script that connects to a Cisco device via SSH and runs a show run, which would also that would also basically back up the configuration because I'm pulling the running configuration of the file. So I've got my lab Cisco device fired up, and first thing I'm going to want to do is verify that I can SSH to it. So I'm going to do SSH, and that's this the Linux command, and my username for the device, IP address, and then enter. It said, unable to negotiate, port 22, no matching key exchange method found, their offer, Diffie-Hellman, group exchange SHA-1, Diffie-Hellman, group 14, SHA-1. So this is where we get into a little bit of Linux troubleshooting, is I can do SSH, help, and it told me what the error is right there, no matching key exchange method found. So let's see if in the help I see anything about a key exchange. And Cypher would kind of stick out to me. That's one potential. And then I don't see anything that specifically calls out a key exchange, but we do also have this option down here, which means I can go into the man page of SSH. And let's see, so selects the cipher specific encryption cipher specs as a common ciphers. All right, well that doesn't look like what we're looking for because nothing in there about a key exchange. So if I come down, I'm going to look for that O option. O can be used to give options in the format used in the configuration file, which means that all of these are in the SSH configuration file, but we can add them to the command. This is useful for specifying options for which there is no separated comma line flag, so it doesn't exist in the configuration file. Full details on the options listed below and their possible values, see SSH config. So I could also do a man SSH underscore config. Let's see if there's anything about a key exchange method. So it's all in alphabetical. So keyx algorithms. That looks pretty promising to me because Diffie-Hellman key exchange is an algorithm. So we'll go ahead and use that option and see if we can't just figure it out. So I'll do a quit to get out of here. We'll do SSH swanso sj at 192.168.1.10. Then I'll throw out the option flag, and it was keyx al. And I don't remember, so I'll just double tab, and look at that, it filled it in. So it's keyx algorithms equal to, and then I'll go ahead and grab their offer, which was this Diffie-Hellman. I will copy that, and then I will paste it in. Let's see if that worked. Oh, look at that, it did. Are you sure you want to continue connecting? Yes, I do. Permanently added that key, so now I got to enter in my password for the device. And now you can see I'm SSH'd in, so I can do a show IP interface brief. All right, cool. Do a show run if I want to. And there you can see it's got paging. All right, so there's everything for that. And now I'm going to go ahead and exit out of here and clear my screen. So we're done with that SSH session. Now we're going to want to do the same thing, but we're going to connect via Python. So I'm going to enter into my Python interpreter, and we will do a import Netmiko, and we will do the dir against Netmiko. And we can see we've got quite a few different options in here. So I know I'm connecting to a Cisco device, and I see down here we got Cisco, Cisco base connection, and it looks like that's all the options for Cisco. So let's go ahead and do a help on netmiko.cisco, and then help on package netmiko.cisco and netmiko name, package contents, and then you can see we've got some good stuff on connecting via SSH. Here it tells us all of our classes. Netmiko base connection, and if I keep going, I'm looking for Cisco iOS, which I could even, you know what, I can just go ahead and go help, and there it says package contents is Cisco iOS, so I'll just grab that and I'll copy it. We'll quit out of here. Let's see if we can't get any help that way so that we can better. All right, there we go. Help on module Cisco iOS. Class method, and then we still see the Cisco base connection right there. Okay. Class Cisco iOS base, and then there it's giving us args, keyword args, common methods, and then there are the methods defined. And there, did it say that up at the top? Let me see here, common methods for iOS, both SSH and Telnet. Okay, cool. Method resolution order, and then we've got, this is the first resolution order, so let's go ahead and take a look at that before we get into this. So we'll do Cisco iOS base, so I'll just go ahead and copy that. We'll quit out of here, and then we'll do a help netmiko.cisco. I'll paste in Cisco iOS base, and then there we've got Cisco common methods for Cisco iOS resolution order, and then it's got Cisco base connection.cisco base connection. Okay, so that's that class. Help on the Cisco class and the module, common methods, method resolution order. All right, so it's going to look at this one first. Self, arguments, and keyword args, and then we can see the different parameters right here. So it's asking for IP, host, username, password, and I'm not going to go through all of the options because you can see there's quite a few of them. But down here you can see methods inherited from the Cisco iOS base connection, and I thought there was a part that said that this was inheriting from there it is, static methods inherited from Netmiko base connection dot base connection. So just for good measure, let's go ahead and take a look at that real quick. So Netmiko, and then it said this base connection up here. So I'll do a copy. Whoops. Copy help Netmiko dot. Paste that in. Help on class base connection and module base connection. All right, and then it says class base connection, and then here we can see it's asking for IP, host, username, password by default is set to none. All of these by default are set to none. We can set port, device type, and then we start to get into like verbose is false, and delay factor, a lot of stuff, but we can see that almost everything has a default value, which is good. But we need to pass in some of these values like the IP, the host, the username, password, and device type. So let's do Netmiko dot, let's take a look at that Cisco again, or Cisco underscore base underscore connection, and then Cisco base connection, netmiko.base connection. So, all right, so that's telling me that it inherits from that base connection that we were just talking about. And then Cisco base connection is Netmiko SSH class for Cisco and Cisco-like platforms. And then Cisco class base connection. Okay, cool. Now I know just from working with Netmiko, you can read through all the documentation you want to learn more about it, but that they have this Netmiko dot, and that's this connect handler. So if I do a help on that, you can see there's not much, but it says help on function connect handler and module Netmiko SSH dispatcher, and it says connect handlers accepts arguments and keyword args. Factory function selects the proper class and creates objects based on device type. So we don't need to specify this is a Cisco, this is a Fortinet, this is a NetApp, an HP, a Dell device. We can just use this connect handler, and based on the device type from this base connection, which we saw right here, device type is set to 0 by default. Let's see if it gives us what our options are for device type. Device type, class selection based on device type. Device type equals a string. And you can actually go look at Netmiko's documentation online to see the different device types that it requires. I thought there was going to be some examples in here. I could be wrong. Thought it listed it. Let's try do device type. Let's see if that does anything for us. Nope. Let's see if we can't get rid of this base connection and see if device type shows anything. Nope. Alright, so yeah, you'd have to go online and check out their documentation. I'll continue to look to see if I can't find it somewhere available locally, because usually there's a way to look up almost anything locally so that you don't require an internet connection, but it is always handy. Okay, so we'll do import Netmiko, and actually we already know, so from Netmiko import connect handler, and let's go ahead and finish this off in Atom, shall we? So since I'm already in here, I'll go ahead and quit. Clear list. Alright, Python directory then. Alright, so I'll do a touch and we'll call this netmiko.py, and then I'll open this up, go to my netmiko.py, and I'll add a comment at the top. Quick script to connect to Cisco devices via SSH. Alright, so we already know what the first one we need is from Netmiko import connect handler. Make sure I had that right, because it did not help me out, but I don't have Kite installed on this either, so I'll go ahead and drop into the interpreter again. Import Netmiko, and then we will do a dir on Netmiko just to make sure I have the spelling right. Why do I not see everything? Help Netmiko. Oh, it's because it's grabbing the Netmiko dot. Okay, so we have to change the name of that. Clear list, and then we'll do remove netmiko.py, and we will rename this to touch ssh cisco.py. That's better. And now let's get back into Python. Import Netmiko dir Netmiko. Alright, so connect handler. Copy that and just to make sure I got it right, and then I'll paste it. It looks like I did. Sweet. We know we're going to need a username and password from the user, so we'll do user name equals input. Please enter your SSH username. right, and we're going to need a password as well. And to do that, we are going to need to import getPass. So from getPass, import getPass. And again, we can always come in here and do a import getPass, do a dir on, if you're wondering how I just knew that, because I've worked with this for a while. So getPass, and then getPass is right there, and you can continue to look in stuff into that module for all of its options. So I'm just going to do a from import. That way I only need to do getPass, and it's please enter your SSH password. Okay, but now when we looked at that that documentation, we still have, so there we're collecting the username and the password, but we still need to pass in a device type and an IP address. So we'll go ahead and do device equals, and then we'll create a dictionary for this information, and we will put IP. And the IP of my lab device, and this does need to be a string, otherwise it would error out because it's not going to recognize an IP address. IP, and then we'll do username equals the username variable we just created. Password equals pass, and then we still need this device type, and I know from working with Netmiko that it is Cisco iOS, and then we'll end the dictionary. Alright, cool. So now we need to actually make the connection. So I will do a C for connection equals connect handler, and then we will pass in, so we're passing in keyword arguments. So I could have multiple lists of dictionaries. I could have a list of dictionaries where I'm passing in multiples. So from our, there we go. From the section on functions, classes, and methods, you'll remember we need to pass that, and then we will do device. Connect C equals connect handler, and then device. So let's just go ahead and run that real quick and see if it works. So I'm going to go ahead and save this. And although we can run this stuff, directly from Atom, I'm going to go ahead and go back over here just for demonstration so that we can actually see it in action. It's not going to probably return anything for me though. So let me go ahead and quit list, but I'm going to go ahead and run it anyways because it doesn't hurt anything. And we'll run the ssh cisco.py, python ssh cisco.py. It did not execute. Why not? Don't tell me I have to put the shebang in there. Shouldn't. Oh, it's because I wrote all this still in the netmiko.py file. Okay. Copy SSH Cisco. There we go. Save. Now if I go back, it should work. Python SSH Cisco.py, and it detected an error. Import error, cannot import name, connect handler from partially initialized. Okay. So I've got to correct that, and it's going to be import netmiko dot, because I'm calling the package there, and now I just want to import just this one piece, which is not a method or a class in itself. I'm importing just this connect handler. So let me save that. And I wanted to do this so that you could see me work through some of these. But if you'll notice, it says import cannot import name, connect handler from partially initialized module Netmiko, most likely due to a circular import. And that's actually telling me, it's pointing me to the fact that my import statement was wrong. So I'll do import netmiko.connect handler. Okay, and let's go ahead and see if that worked. Did I save it? That's not right. Okay, it means I got to go back to my code here, and whoops. Thanks for adding that to my favorites. I appreciate that. All right, so got to do a little more troubleshooting right here. And what we'll do is, let's go into Python, and we'll do a Netmiko. We have to import Netmiko. We cannot import. I didn't import the name connect handler. That's why I need to get rid of this entirely, because it's picking that up. Whoops, come on. Let's go ahead and delete that. Move to trash. Close it out of here. Don't save. Let's go back to ssh.py, and now, because now I realized it was a name error, so I'll do, let me try the from Netmiko import connect handler again, and we'll save that. Sorry about that. Okay, quit, clear, and let's go ahead and just run that again. All right, there we go. That looks much better. So, and then SSH password. All right, no errors, which is the important thing. We didn't run a command yet. So let's go ahead and go into Python. We'll import Netmiko, and we'll do a dir on netmiko.cisco and see what our options are. We've got file transfer. So let's do Cisco iOS SSH. I'll copy that out of here. Dot. And I'll paste. Let's see what our options are. There we go. So what we're looking for is something to send some commands. So we can get to the end, check config mode, disable paging, connect, config mode. Lots of options, but we want to send config, send command timing. Send command, there we go. So now I can do a help on copy, paste, send command. There we go. And then for send command, it looks like we have to pass in self and then the command string. And everything else seems to have some default values, so we will leave it up to the default values to make sure that this works. I'll quit out of here, and let's go ahead and send it a command. So we do need to import that, so it's from Netmiko. It actually, no, because we imported connect handler, so it should import the entire Cisco iOS for us. We're passing in the device, and we could add more if we wanted to. So now we need to do output equals C, which is our value for the returned good connection. So here we've made the connection and stored that connection as C. So we will do output equals C dot send command, and then we will send the command show run. Save that. Now let's go back here. Oh, so if I do this right now, it's simply going to send that command and store that value as an output. So what we can do is I'm going to import, so I know I've mentioned it before, because I know that, actually we'll do it both ways. So I'll save this, just so you can see the actual power of what I'm talking about. And we'll do a Python, Cisco, what was my name? It should be Cisco, SSH Cisco. So Python, SSH Cisco.py, enter my username, my password. Alright, so it should have just ran the command, and then it didn't show anything, so that means we need to print the variable output, but you'll notice it did not error out on us. So we'll go ahead and run that command again, or run the script again. so SJ, and my password. And there you can see it actually printed the configuration to the screen. I was expecting it, honestly, to show up as a bunch of junk to where it wasn't pretty, but I forgot that it pulled this via a terminal, so it is automatically formatted for us. So we'll have another example of where to use pretty print in the future, because I do know the APIs are not that nice. But really quick here, you can see that we can do an import OS, and instead of printing that output, now we can do file open, and we will call this backup.conf for configuration. We'll open it as X in case it doesn't exist, and then we can do f.write output, f.close to close the file. And let's see what happens. I just saved that, because if I don't save it, it's not going to pick it up in the terminal. So let's see what happens when I run that again. List. So there is nothing called backup.conf, as you can see. So I'll even do a list. Back. No such file or directory. All right, cool. So clear this again, and let's run that script. All right, nothing happened. So let's do a list and see if we have that backup.conf file, which we do. So I will now cat it out. And there you can see we have just created a backup of our configuration. So you can see just by using some of the basic help dir functions that we were able to kind of read over some of the base documentation, create a quick script that accepts your username and password, a device as a dictionary, and then it makes a connection to the device. Again, we could add a list of dictionary devices, and then it does a send command of show run, opens a file, writes the output of show run, which is the same thing as backing up the configuration of the device, writes the output to the file, closes the file, and then it created a backup configuration of our device. So pretty cool stuff. And that pretty much does it for this week's module, or this week's lecture. Next week, we're going to start to get into some error handling and expand on this Netmiko script that we've just created. And I will post a Cisco CSR 1000V, which is a virtual router, to Canvas, so that you can actually set this up and run it in your VMware Workstation Pro environment on Horizons. It should also be on your Horizons machine by default, but I'll also make a video on how to set that up real quick. That way you can actually run through this Netmiko script and get it to work. So I hope you enjoyed this lecture, and everyone have a great rest of your week. Please enjoy the labs. Always reach out to me if you need any help. Quickest way is via text message. You can also hit me up via email or as a message on Canvas. So thank you very much. All right, in summary, we've gone over importing modules, how to learn the different modules, some different useful modules that are available in Python, such as OS and date and time. We've learned how to go over the module itself using the dir function, built-in help, so that we can learn more about them and what it is that they have to offer. We've learned that we can build our own custom modules with our own classes, methods, and functions into them, and then we can import those modules as we do any other Python package or one that we downloaded. And then we've gone over parsing data, which was really an introduction to the different data formats that you're going to see, such as CSV, JSON, XML, and YAML. And then finally we did a little demo where we went into our SDN VM, looked at some of these different data formats, interacting with them in Python, and then looking at, some of the different packages that we've been talking about and installing. And then we started building out our Netmiko script to run some commands against a network device. If you have any questions, please direct them towards the discussion board. Chances are, if you have that question, someone else in the class also has that exact same question, so it's good to use each other as peers. Throw out your questions and learn to learn from each other. It's a very good learning tool. If you have any questions for me directly, you are always welcome to shoot me a text. All of you have my number. You can also reach out to me via Canvas on the Canvas Messenger, or you can shoot me an email, but the quickest and easiest way to get a hold of me is simply by shooting me a text message. So I thank you all for your time, and I hope you enjoyed this week's labs on getting started with Python modules. Thank you.